All right, let's dive straight into this explainer. Today we're looking at a massive cosmic mystery, one that actually has the entire astrophysics community completely divided. What you are about to hear is a true scientific detective story. We found a bizarre anomaly out in deep space, and some of the brightest minds alive are fiercely debating what exactly it is we're witnessing.
So picture this, an invisible object hurtling through intergalactic space at an absolutely mind-boggling 3.5 million miles per hour. That is actually one of the leading theories for what we're dealing with here, a runaway supermassive black hole that has literally been violently ejected from its host galaxy. Just let that number sink in for a second. 3.5 million miles per hour. It's both terrifying and thrilling, isn't it? Getting a speeding ticket at that rate would pretty much ruin your whole cosmic epic. But as we'll see, it is definitely not the only explanation on the table.
The crazy part? This anomaly was discovered completely by accident back in 2022. A researcher named Van Dockum and his team were actually using the Hubble Space Telescope to look for something else entirely: dwarf galaxies lacking dark matter. But while reviewing the images, they spotted this weird, unexplained, long, thin streak of light. It was a totally serendipitous find. And you know, when you spot something like this by pure fluke, the very first thing you have to do is prove it's real. That it's not just a cosmic ray hitting the camera or some random data artifact. Once they confirmed it was genuinely out there, the immediate next question was, okay, how far away is it?
So, to figure out what on Earth, or rather, what in space they were looking at, scientists first had to measure its distance using something called redshift. Because our universe is constantly expanding, light from distant objects gets stretched out into longer, redder wavelengths the further it travels. It acts kind of like a cosmic waymarker. By splitting the streak's light into a spectrum, astronomers found out that it sits an astonishing 7.8 billion light-years away from us.
And this really hits home the sheer scale of the mystery here. At 7.8 billion light-years away, for us to even be able to detect it, it has to be huge. And it is. At 150,000 light-years across, this faint streak is actually larger than our entire Milky Way galaxy, which only spans about 100,000 light-years and holds 100 billion stars. So this is no small scratch on a telescope lens. We are talking about a colossally massive structure.
Section 1. Suspect 1. The rogue supermassive black hole.
Now, I know a rogue supermassive black hole sounds like pure science fiction, right? But computer simulations have actually long predicted this exact violent sequence of events. If three massive galaxies merge, the three supermassive black holes at their centers start this chaotic gravitational dance. Simply put, three's a crowd. Eventually, the chaotic math slingshots one of the black holes completely out of the galaxy, casting it deep into intergalactic space. Now, despite these predictions, we had never actually found physical evidence of an eviction like this out in the wild.
So, how do we know a black hole might be there if it doesn't emit any light itself? Well, we look for its chemical fingerprint in the surrounding gas. They noticed an immense glow of oxygen compared to hydrogen, sometimes 10 times as much. It takes a massive amount of energy to make oxygen glow like that. The team concluded that this light is best explained by a trail of newly born stars sparked into existence as the black hole violently tore through the gas.
Using incredible detailed data from the James Webb Space Telescope, the team realized the streak perfectly matches the bow shock of a black hole plowing through intergalactic gas. Think of it like a boat's wake. Just as a speeding boat creates a distinct wake in the water, a black hole slamming into gas at 3 million miles per hour triggers a massive shockwave. And that shockwave leaves a straight trail of glowing oxygen and newborn stars right behind it. Section 2. Suspect 2. The Edge-on Galaxy Counter.
You know, the scientific process thrives on debate, and man, this case moved incredibly fast. From the initial Hubble discovery in 2022 to the black hole theory in early 2023, a counter-theory was published almost immediately. And amazingly, recent James Webb data ended up adding fuel to the fire for both sides of the argument.
The absolute crux of this counter-theory is that we aren't looking at the energetic wake of a runaway black hole at all. Actually, they argue we're just looking at a perfectly normal, flat disk galaxy viewed directly from its edge, which makes it look like a streak to us. Researchers found that its speed and mass perfectly match the standard rules for known disk galaxies that are much closer to home. This counter-argument relies really heavily on the new chemical data. While both teams totally agree that the oxygen levels are surprisingly high, the counter team points out something crucial: the nitrogen and silicon levels are incredibly low. In astrophysics, we use specific chemical thresholds to separate supermassive black holes from normal galaxies, and these exceptionally low levels map the object firmly into the territory of a standard star-forming galaxy, meaning completely lacking a feeding black hole.
Section 3. The verdict and the future.
So, with two incredibly strong arguments, where do the experts lean? Well, the specialist in our source material actually tends to favor the runaway black hole theory. Why is that? They point out that the object's extremely sharp edges and intricate internal structure totally defy what we'd expect from a smooth, typical disk galaxy. And as for those chemical thresholds, well, if this is an ejected supermassive black hole, it's such an extreme, rare event that the standard rules for normal galaxies simply might not apply anymore. To definitively settle this debate, we literally just need to find more of these objects to compare to. But here is the massive catch. Despite operating for over 35 years, Hubble has captured less than 1% of the entire night sky. Let that sink in.
Over 99% remains completely unsurveyed at that level of sensitivity. Finding RBH1 was an absolute fluke. We desperately need a bigger lens.
Thankfully, we don't have to wait very long at all. Enter the Nancy Grace Roman Space Telescope, which is slated to launch at the end of August 2026. Because it's designed for massive wide-field surveys, it will capture roughly a 20th of the entire sky with the exact same staggering resolution as Hubble. This is going to give us a massive, unprecedented dataset to hunt for more of these glowing streaks.
Finding more candidates is going to let us compare brightness, color, and chemical ratios across a whole population of these things. But what's the ultimate smoking gun needed to definitively close this cosmic case? It'll be detecting invisible X-ray or ultraviolet emissions right at the tip of one of these streaks. That specific emission would come directly from the material violently spiraling into the black hole itself as it plows through space.
So, as humanity prepares to scan the universe with unprecedented scope, we are left wondering, will the Roman Space Telescope finally catch a runaway supermassive black hole red-handed? Or will we discover a strange new population of incredibly flat galaxies? Either way, solving this is going to fundamentally rewrite our understanding of how galaxies evolve. It just goes to show, the deeper we look, the more incredible the mysteries become. Keep your eyes on the stars, and we'll see you in the next explainer.